Yo guys, welcome back to another episode. Today we're filming episode 113. We got a Chansey today. Let's take a look at the sound. Chansey, 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 Chansey. There we go. There's our sound of the day. We're gonna jump in straight into some problems today. Probably do a little bit of problems, and then we'll call it a day like usual. I got some stuff to work on later this evening, so yeah. Looks like we got a pretty easy problem today. 91.1% acceptance rate. Building an array from a permutation. Let's take a look at this problem. Given a zero-based permutation num 0 index, build an array ands of the same length where ands I is equal to nums I for each 0 I and nums dot length and return it. A zero-based permutation nums is an array of distinct integers from 0 to n minus 1 inclusive. I'm gonna sneeze. No, I'm okay. Oh man, I'm gonna sneeze. Oh. I don't really understand what I'm meant to do here. The array as is built as follows. You solve without using extra space or one memory. Well, reply what's said in the statement. Given a zero-base nums, 0 index, build an array ands of the same length where ands I is equal to nums I. Where ands I is equal to nums I. A little bit confused. I don't really understand the problem. Don't understand anything. Some of the tasks still don't understand anything. I think the description is a little bit confusing today. Not gonna lie. Let's take a look at 1920 build array from permutation. You're given an array of integers called nums, which represents a permutation of numbers. A permutation is just a rearrangement of the elements in an array. Okay, I knew that. Task is construct a new array answer where each element is determined by looking at the value in nums at the index and corresponding to the current. If okay. The task is to construct a new array answer where each element is determined by looking at the value in nums at the index corresponding to the current index of answer. The new array answer will be formed by using the value at each index in nums. So for the index I in answer, you look at nums I and set answer I to be nums of nums I. So why is 3 here? 0, 1, 2, 3. I still don't get it. index 0, num 0 is 0. So we need... This one is 2. Now we need nums 1 is equal to nums 2. Nums 1 is 2. Okay, we see that, yeah. Now we need nums of num 0. Okay, I think I understand it, but I am a little confused. So let's create our res array. Let's loop length nums, right? Res I is equal to nums of Is the length always the same? Turn res. Okay. Is this the answer then? No way. What a stupid question, bro. Like, I still don't understand the question. I don't know, like, this comment is totally true, bro. Interesting problem. Not even gonna try the old one solution because I don't even want to. Let's try some of these we haven't done. Path sum 3. Given the root of a binary tree and an integer target sum, return the number of paths where the sum of the values along the path equals target sum. Oh man, this is a disgusting problem. The path does not need to start or end at the root or a leaf, but it must go downwards, traveling only from parent nodes to child nodes. Oh, bro, this is a terrible problem. Like, so maybe like Can we just go through each path and then call the DFS function and run DFS on it? I feel like that would be... I'm going to work at McDonald's. The fries in the bag, bro. It's crazy, man. Can we start here? Pass an I. It's in the node. DFS node. Can we just keep looping? So like, while node doesn't equal null, we do left, right. While not node, we go left is equal to. We could probably loop through using BFS, right? And run DFS from each node. Let's see if that... Okay, let's think here, right? So we could do while queue, right? We can from collections import DQ, right? have our Q is equal to DQ, right? We can Q dot append, right, the node, okay, for in range length nums. We can shit, wait, is it Q dot pop left? Maybe, I think we do this inside the loop, right? Because if we're looping, we're seeing there's something in there. We're looping through the range of items in the queue. Length queue. Node is equal to Q dot pop left, right? Then we want to do something, right? Probably want to call DFS on this node, so let's do DFS node. And then we add right. Then we want to do, well, Q dot append, no dot left, Q dot append, no dot right. Right? This is DFS, right? I just want to make sure I'm doing this right. Sorry, BFS, is that what I said? I don't even know. No dot right, Q dot append. Let's just check our previous problems. I know this is a typical, obviously this is a BFS problem right here. Cream soda Fago, damn I'm still dreaming. Okay, yeah, we're doing it right. I think it just looks better. I'm just gonna do that, right? So we get our node, pop left, we do something, we call DFS on that node, right? And then we append all our stuff, right? We have to call DFS on our node up here, so we need to define DFS, pass in our node, right? And then what we want to do is we want to loop through and find each thing that adds up to target sum, right? So our base case would be, okay, probably need a cur or two actually, right? Our base case would be, well, if cur is greater than target sum, right? Then I assume we would probably just like return, right? Return false, right? If cur we don't need to pass back the thing, we just need to have some sort of count variable, right? So count is equal to 0. Add a non-local, right? Which is greater than that. If cur is equal to target sum, then we can turn true and count plus equal to 1. Right? So we don't even need this. We can return true, right? So if we can just do, well, if node DFS node, we can do count plus equal to 1, right? Come down here, you can return count, right? Check if the target sum is true, right? Otherwise, we would want to just, if not node, then we just return, right? I guess we can check. If node dot left, let's add node dot left, node dot DFS, node dot left. If node dot right, we can do DFS node dot right. If we get to a empty node, right, then we can technically just return false. So I believe, let's see what this gives us. Invalid syntax. Ugh. Sorry, this has to be root. Cream soda Fago. Damn, I'm still dreaming. Let's see. Node dot has no attribute left. Okay. Let's just call our DFS, right? And then we just check up here. We can just do, okay, well, if not node, we just return false. Oh, sorry, I guess we can just return. Well, I guess technically if we do see an empty node, we can return false, right? Like there's no attribute left. Why are we getting... shouldn't be appending any empty nodes. Oh shit. Well. Why are we getting no attribute left? Oh my god, am I appending a list? Oh jeez. Expected 3, we're getting 0. Okay. So we get our node, right? So let's say we get this node. Okay, we check our base cases. Well, it doesn't, right? Then we go DFS node.left and we pass in cur, right? Oh shit, we're not even adding up cur. Cur plus or equal to node.val. What's wrong with the DFS function? You're not using the return values in the recursive calls. Turn DFS left or DFS right. Oh. Now another reason they hate on me. We're getting 2. We're getting 2. Why are we getting 2? I think it's because of this return statement here. I think the issue is this return statement here, but I'm not really 100% sure. Okay, we designed it wrong, right? So turn 0. Okay, plus equal to node.val, right? If cur is equal to target sum, else 0. Try and count. That's so weird. Oh, whoops. Count plus or equal to DFS node 0. Add here, we return count. Bro. Done type object has no attribute left. I don't know why this it doesn't like this. What is this error? Attribute error. Attribute error. What's going on here? Oh. We have to check. Okay, like if not none. If not root, turn 0. Wow. Can't believe that solution actually worked. Doing a BFS and then a DFS? Like, bruh, what? Bro, this is like a BFS one. You're also given an entrance. You're also given the entrance of the maze, where entrance is equal to entrance of row, entrance col denotes the row and column of the cell you're initially standing at. In one step, you can move cell up, down, left, or right. You cannot step into a cell with a wall, and you cannot step outside the maze. Your goal is to find the nearest exit from the entrance. An exit is defined as an empty cell that is at the border of the maze. The entrance does not count as an exit. I feel like it's a pretty easy problem. Like, I didn't even notice she was wearing a mask. That's so funny. That is so funny. All right, let's take a look. So obviously, my first intuition here is that this is definitely a graph PFS problem, right? We're using, I guess it could be DFS too. I mean, I think, but for me, like, I don't know. I mean, I'm not a great programmer. Like, you know, for me, like when I look at a problem like this, I always think of a graph. I always think it's like 90% of the time going to be a PFS problem. See how many questions I've solved now I think about it. I must be getting close to 400. I'm at 371 now. Damn, was I lead coding this time last year? May 12th? What is today? May 6th? Right before I started my internship, I think. And I didn't do any until I went back to college. Fair enough. Okay. Gotta stop reminiscing. Let's lock into this problem. Okay, so let's import some sort of queue, right? So from collections, import DQ, right? Okay, well, I guess we gotta make our rows. So let's make our rows. Rows is equal to the length of maze. Our calls can be the length of maze, right? I always like to just make sure this is working properly, so let's print our rows and our calls. Okay. So we're given an entrance, 1, 2. We're given the maze. We got 3 and 4, right? So now what we want to do is we probably want to why would we want to loop through our rows and columns? Well, we have a starting point, right? So I guess we have to go from that starting point. Okay, so how can we do that? Well, let's create a directions array, right? So our directions would be, we can go up, down, right, and left, okay? to go up, up would be -1, 0, right? And down would be 1, 0. Left would be 0, -1. Oops, 0, -1. And then right would be 0, 1. Right? Let's just confirm this. See what this thinks here. You wrote right. That's right, yeah. This is meant to be left. Whoops. Left, right. Okay, we got that. So obviously we're gonna need a visited set, right? I know that. We don't want to visit the same cell. Obviously we want to start our queue, right? So we go while queue. Okay. We definitely want to pass in, well, we need to create our queue. Queue is equal to DQ, right? And then we want to pass in queue.append. We'll make it a tuple entrance, right? Entrance. Okay. We add that to the queue. Then what's from inside the queue? We want to do row call is equal to queue dot pop left, right? Then we want to loop through. So for drdc in directions, okay, we want to check create our new row is equal to directions. Our new call is equal to, row plus dr, call plus dc. To new call, new row, new call. Okay, then we want to check, okay, well, and walls are represented by plus, so we have to check if it's inbound, right? So what we want to do is we want to check, well, if zero is less than or equal to, what do we return here? Are we returning how many different ways there are? Okay, so if 0 is less than new row, but it's less than rows, and 0 is less than or equal to new call, but it's less than calls, and we want maze, what is it? New row, new call is equal to a dot, right? Because that represents an empty cell. If 0 is less than new row is less than rows, 0 is less than new calls, less than calls, and maze is that. And it's not unvisited, and new row, new call, not invisited, right? Then we want to put on one line because it kind of annoys me sometimes. And it's not unvisited. Then what we want to do is we want to add it to visited. Visited.add new row, new call. Okay. So we don't revisit it again. Then we want to check, well, is it a border cell, right? So the way we do that was we would do, well, if new row is equal to 0, or new row is equal to rows minus 1, or new col is equal to 0, or new col is equal to cols minus 1, then we can count, right? Because we have found an exit. Okay, so let's add a count somewhere. Count is equal to 0. Okay. I'm looking at my code, and it specifically mentions here, and an exit is defined as an empty sum. Wait, the entrance does not count as an exit. We would have to, I think, fix that. So, the way we can do that, I'm trying to think. Let's get the main functionality done though. Okay, we found it's a border. We added the count. I think that should be good, but I feel like I'm missing something. We've added it to visited. Okay, so I think what I'm gonna do is I'm gonna add I'm just gonna return a count here. Right? Let's see if that gives us invalid syntax. Missing equals here. Damn so Fago, and I'm still dreaming. She hate on me. I don't know the reason. Okay. If count does not equal 0, else minus 1. Okay. So we start. Okay, so here we're starting at a border cell. So we got to handle this case here, right? So I guess let's like draw this really quick. So we have wall, wall, wall. We have empty, empty, empty. Then we have wall, wall, wall. So I believe this is the only one we return. Well, we start at 1, 0. So one zero would be, I think, 1. Jeez, I'm gonna have to get this to visualize. I feel like I'm doing this wrong. 1926. Nearest exit from entrance in maze. Can you visualize this maze? Okay, that's what I thought. Okay. Okay, the entrance is 10. Okay, so I was right. Okay, so the entrance is right here. Oh. 2. The entrance is right here, right? Jeez, man, this shit is so laggy, dude. Like, okay, so our entrance is here, right? So this entrance doesn't count, or does it? The entrance does not count as an exit. So how does this return 2 then? Does it maybe go here? And then when we go here, it has here and here, right? As exits? I don't know. I don't know. Let's just try that, right? So so we go here, we go roll call, we start looping, and we instantly find our next one, right? So why does this return 0 though? I feel like it should at least return... I feel like my code should at least return a 1. Because we're instantly computing straight away. We're not even checking the entrance, right? So technically we're dealing with the case, right? We're not... You wrote a new column. I really don't know. Because I feel like I should be returning at least 1 in this. I'm going to have to check. I'm kind of stuck. I need a hint. Wait, we give it a... It must have, you can move one cell up, down, left, or right. You cannot step into the with the walls on. You cannot step outside the maze. Your goal is to find the nearest exit from the entrance. Return the number of steps in the shortest path. Oh my god. I thought we were incrementing. Oh my gosh. Okay. The shortest path. Okay. Well, that changes things a little bit. Okay, so we can have a count here, counting the path, right? Do row call, right? Loop through. If it loops through, we can increment our count, right? Then if we find a thing, we can have like a min count variable, right? Where our then if we find here, we can calculate our mid count. We can do, well, min count is equal to min count, and we return min count. Return min count if count does not equal 0, if min count does not equal 0. Output -1. Okay, this needs to be set to float -inf. I'm getting a null value. Which means we're not finding anything, but how are we not? Oh. Return min count if min count does not equal float. Wait. Oh shit. Does not equal to. Okay, float. Return min count if min count does not equal float inf, else -1. Let's try this. Okay, we're getting -1 here. We should not be getting -1 here. Why are we getting -1? I feel like this should be working. Oh, jeez. My God. Sorry. Sorry. We need a... Passing out count. Right. We increment first. Call it again. To add this. I think we can get rid of that now. Not enough values from back. Expected 3, got 2. Oh shit. I think we need that back for the initial. Oh shit, no, we can... Temp row is equal to entrance 0. Temp call is equal to entrance 1. Let's do temp row, temp call. Bro, this is so stupid. Like, what is going on here? Bro, what is happening here? We're pending count. Okay, so I think the way to fix this is we need to get rid of this and do count plus or equal to 1. Or count plus 1. Bro, this just pissed me off. Output 0. Oh, wait. Oh my gosh, we're not even adding it back, dude. Oh my god, bro. What am I doing? Bro. Append. New row, new call. Count plus 1. Is it a dot add, new row, new call? Q dot append, new row, new call, count plus equal plus 1, right? But are we checking it too early? Is that why we're not? Bro, why do I keep deleting this stuff? Bro, this problem's pissed me off. Like, okay. I think this isn't gonna submit. I don't think we're adding properly. We're so we're incrementing our count by 1. This is what I'm thinking, right? So we have our thing here. We go through this loop, right? We're checking up, down, left, right? So we go up, left, right? And we go count plus equal to 1 to go up, because up would be first, right? And then we'd add it. Our count automatically increments. And then when we go left, it increments again, right? So technically we're getting the wrong value. For some reason, we're not. Let's try and check it first. We check if it's the border cell, then we append, right? Count +1. We do count plus equal to 1. Then we update our min here, right? Min count is equal to min count count. Min to count, dude. Jeez. Min Linux. Okay. 0 new call is equal to this. We increment our count by 1, right? If we get to the border cell. Okay. And then we would return. Otherwise, we visitor.add this thing. And then we append +1 to the queue, right? We append min count. I don't think we want to count min count +1. I think this should submit. Bro, what am I missing? I put 2, expected 12. Bro, what? Column, your goal is to find the nearest exit from entrance. Bro, I don't know. I don't know what I'm doing wrong. What is wrong here, bro? You're visiting a cell and then checking if it's an exit. The issue is that you're making it visited before checking if it's an exit. No, I'm not. Bro, this is insane, dude. Like, literally insane. I don't want to. Oh my god. Blueberry Fago, damn, it's all draining. They hate on me. Now I know the reason. Okay. Output 2, expected 12. Like, what? How? Oh, maybe I'm not. Maybe it's going. Let's check if it's a empty cell out here. So like, if this, then we can do visited.add. Do tempora. Maybe that's what's happening here, is that, let's do this. Check if it's a border cell and append it to visited. Tempora, temp call, visited.add, temp row, temp call. Bro, please, bro, please. Oh, thank God. Thank God. That was my issue, dude. Oh my God. AI is useless, man. Wasn't even telling me that was the issue. There we go. Okay. Solved it, dude. Thank God. Okay. Let's do one more problem. That was like an awful problem. Now I know the reason they hate on me. Lead nodes and BST. Kth largest element in an array. Maximum subsequence score. Let's take a look at this one. Okay, you're given a zero index integer. Arrays nums1 and nums2 of equal length n and a positive integer k. You must choose a subsequence of indices from nums1 to the of length k. These long questions, man, just like too much reading, bro. Like, You must choose a subseries of indices from nums1 of length k. For chosen indices I minus I, your score is defined as the sum of the selected elements from nums1 multiplied with the minimum of the selected elements from nums2. Turn the maximum possible score. I don't really understand this question, dude. To be honest. I feel like I don't understand any question. 2542 maximum subsequence score. Graph Leetcode problem to pick people up in car. Carpooling. Is that a is this? Oh, it wasn't this one. We're gonna skip this one. I'm gonna do the number of provinces. We can do that one tomorrow. Man, I keep punching this thing, bro. Okay, they're in cities, some of them are connected, while some of them are not. If city A is connected directly with city B, and city B is connected directly with city C, then city A is connected indirectly to city C. Turn the total number of provinces. One 110 001. Can we convert this matrix technically into an adjacency list? I'm gonna try to. Let's do like, let's do grid, right? Let's do for row in, let's do rows is equal to grid. Well, it's a triple dimensional array. No, it's not. Rows is equal to the length of grid. Cols is equal to the length of grid of 0, right? Then we can loop through, right? For row and rows, for col and cols, right, for range rows, for col and range cols. If row is equal to col, right? Because if row is equal to col, then it doesn't count, right? So these are the ones we don't want. We only want right? We want these three and we want these three. So all the diagonal ones are gonna be 1, right? Then we can continue, right? We can skip this iteration, okay? That's a we can create a graph over here and adjacency list, right? Loop through this and check, well, okay, if row let's populate the graph first, right? So we would go, okay, well, for I in range length rows, graph I is equal to this, right? If graph row col is equal to 1, then we want to do, well, graph row dot append graph row col, graph row col. Okay. I wonder if this will do it. Return graph. I could be cooking here, or I could be doing something so stupid. I don't know. Like so graph is equal to adjacency list, and then we want to pass in our is connected graph. Connected. Let's print our graph. This index is out of range. Oh, sorry. This is meant to be grid. It's meant to be grid too. think I just did it. I just made the adjacency matrix. Alright. Shit. We want our start to be 1 though. We don't. Oh shit, dude. We have to convert it to being oh my gosh, dude. We have to convert it to being one-dimensional in terms of the can we like upgrade keys to one-dimensional? How can we do that? Can we like loop through? For key in graph.keys. I guess actually technically we probably don't need to, right? It doesn't technically need to be, because we are only returning a count, so it doesn't really matter, right? Like, I didn't think about that. So now probably want to do our DFS function, right? Do like def DFS, passing our node, we need a visited, and we need okay, so we need a visited, we need a visiting. Okay. Let's just start with that for now, right? Here we need to loop through each thing, right? For I in range length, for I in rows. Okay, for I in length grid, right? I'm gonna call DFS, right, on I we obviously need a visited. Visited is equal to set. If I not in visited, then we do dfsi, we pass in visited. Okay, right? Then we increment our count by 1, right? Count plus equal to 1, okay? Because technically we're looking for separate things, right? When we're looking for separate things, we can simply just create another one, right? Okay, then we can literally return an account. We want to look for I think we only really need one visited because okay, well if node and visited, let's just return true, right? I guess we can just return, right? Then we do visited.add node. We loop through its neighbors for I in range length nums. Okay. Neighbor in graph node. Oh shit, we need to pass in our graph. Graph, right? For neighbor in graph node, we want to check, okay, well, a neighboring graph node, we want to call DFS on the neighbor, the visited, and the graph, right? So if neighbor not in visited, then we call it, right? Oh, maybe we don't need this. Right, we call this function. Okay, right? Neighboring graph node. If DFS neighbor visited graph, let's try this. I think this should work. Grid is not defined. Why do we have grid, bro? What the? Oh, length is connected. Alright, range. Local variable count. shit, we don't have a count. Okay. Count is equal to 0. I don't think it really matters being swapped around. Okay, that's what I thought. Will this submit there? Nope. Why is this not working? Give me a hint. Please. Apparently there's an issue here. If our grid of row column is equal to 1, graph row dot append grid row column. Apparently it's just coal. No way, it submits. Bro, what? Why? I don't understand that. Why was that the fix? Okay, I understand. I'm so fuego now. It's dreaming. They hate on me. I don't know the reason. Oh, wait, they did it a different way here. And is equal. Visited said province is 0 for city and range N. If city not visited, start our BFS. What an interesting way to do this. So obviously mine was a little bit overkill. Well, it's a totally different way, but it's okay. Okay, we're gonna call it there. Yeah, I appreciate you guys watching, and I will see you tomorrow. So tomorrow will probably be a shorter video, but we'll be back out again tomorrow. See you guys later.